Okay, hi everyone. Just a short video here to start actually the next topic, which we're going to make a start on before the end of this term. And the topic is called Particle Model of Matter. Now, this introduction video, as I say, will be quite short, just really summarising all the stuff you've done on particles before. So we're looking here at what particles, or the action of particles, the movement of particles is like in solids, liquids, and gases. So hopefully this should be all stuff you've done before. Now, you know my drawing is horrendous, but I'll give this a go. So solids, as you hopefully know, the particles are going to be arranged in a regular pattern. Okay, and so you can see here as I'm drawing it, I'm putting my particles in nice, neat rows and columns. Now, obviously, if you were asked to draw this in an exam, just a tip, draw them reasonably big, like I've done there, then it doesn't take you all day. If you draw tiny particles, you'll be there for a long time and it's a waste of time. Try and make them all roughly the same size, and you can see there they're in rows and columns in a nice regular arrangement. We'll talk about the movement in a second. Right, liquid. Now, this is a very common mistake because people in liquids often draw something like this. The number of times I see this sort of thing, like sort of weird chains like that, and it's just not right, I'm afraid. So that's not what the particles are like in a liquid. Actually, the particles in a liquid are very, very similar to the particles in a solid. The only difference, okay, is that the pattern is not regular. However, there are not loads of gaps in between the particles. Okay, so this sort of thing. So the particles are still touching, but there's no, they're not in a regular pattern. All right, and again, we'll talk about movement in a second. Particles in a gas, as hopefully you know, a lot more spread out, big gaps between them. Now, we know that the particles in a liquid can't have any gaps between them because you may know you cannot compress or squash a liquid. Now, you know you can't squash a solid. If I get this pen, I can't compress it. But actually, it's the same with a liquid. Now, it's very difficult for me to show not being in school, but if you have a liquid in a sealed container where the liquid fills up the whole container and you try and squash it, you won't be able to because liquid can't be compressed because there are no gaps between the particles. Gases, on the other hand, can be compressed. Right, you know that if you've got a bottle, an empty bottle, you can squash it even with the lid on, and that's because you're compressing the gas. All you're doing is moving these particles closer and closer together. In fact, if you do compress it enough, in theory, the gas can actually turn into a liquid, but you really do have to compress it a lot for that to happen. You won't be able to do that with a bottle, say. Okay, just a few other key words then to remind you of, and that is that there are words for these changes of state between each state of matter. So solids, liquids, and gases are called states of matter, and there are words for the transition. So hopefully you know these already. But solid to liquid, think about ice. If you put ice outside on a warm day, what's it going to do? Well, it's going to melt. So solid to liquid is melting. Liquid to gas. Now, liquid to gas actually is a little bit more complicated because there are actually two words. So there's the word evaporating, but you will also probably know if you don't say, oh, I'm just going to evaporate the kettle. You would use the word boiling. Now, there is a difference between these, just to clarify. Boiling is a specific process that happens at one particular temperature. For example, water boils at 100 degrees C. At 100 degrees C, all of that water will turn into steam or water vapour. Evaporating is something that can happen at any temperature. If you imagine a puddle outside, and in fact today it's raining, one of the first days for a long time it's rained, but if the sun comes out later, that water will go, it will evaporate, but it's not 100 degrees C out there. So evaporation happens at all temperatures. Essentially, a few of these particles of liquid get enough energy and can escape from the surface of the liquid, and so the liquid is a little bit of the liquid at least is turning into a gas. Boiling though happens at a very, very particular temperature, and we'll come on to that a little bit more as we go through the topic. Okay, let's look then at the words going the other way. So gas to liquid. Okay, condensing. So that's not very clear. Condensing, that says. And then liquid to solid. We've got freezing. Okay, now there are actually a few materials, for example, iodine is one, carbon dioxide is actually one, where a solid, if you heat it up, doesn't actually even become a liquid at all. It ends up going straight to a gas like that. And that would be called sublimation. Oops, sublimation, or it's subliming as it goes from solid into a gas. So, for example, as I said, carbon dioxide, solid carbon dioxide, you'll never get liquid carbon dioxide at normal pressures. That solid turns straight into a gas. And if you want it, there is actually a word for the opposite of that, which is called deposition, or depositing, I suppose. Okay, so those are all the changes of state. Now, I just want to very, very quickly run through some of the other facts and properties about the particles in solids, liquids, and gases. I'm not going to write all of these down. I'll just talk about them, but you may obviously want to write them down in your notes. Now, we've mentioned a lot of these already. So the fact that in a solid we've got our particles there in a fixed regular arrangement, and that's why a solid has a fixed shape, because all of these particles are close together, regular pattern, and there are strong forces or bonds between the particles. Okay, whereas in a liquid, the particles, yes, they're still touching, but as you can see, it's in an irregular arrangement, and there are much weaker bonds between the particles, which is why a liquid will take the shape of its container, as in it will fill up the bottom of the container. A gas, on the other hand, has barely any forces or bonds between the particles, very, very weak bonds. Particles are spread out, free to move around in the container, and so that's why a gas will fill its container. Okay, it will spread out and fill the whole container. Now, all of these ideas link into the amount of energy the particles have. Because in a solid, the particles actually don't have that much energy at all. Okay, they just vibrate. Okay, they shake around a little bit. They vibrate in fixed positions, and we can see them in their fixed positions there, because they haven't got that much energy. In a liquid, on the other hand, they've got a bit more energy, which is why they can actually move kind of low speed, but they can move over each other, sort of flow over each other, the particles. And then here, in a gas, the particles got lots of energy, so they're moving around freely at high speed because, again, there are no bonds or very weak bonds between the particles. Now, we mentioned earlier about the compression of the particles. A final point I just want to touch on now, and this will link very nicely into the next video, is something called density. Right, now I'm not going to explain density now, but we are going to come back to this in the next video. So a sort of little question for you, I guess, is which do you reckon, in general, out of solids, liquids and gases, has the highest density, and why? And that's a question I'm going to come back to in the next video. Okay, so there we go then. That's our introduction to particles in solids, liquids and gases. And I'll see you on the next video where we're going to start the new bit of the topic. And in fact, that is going to start off by looking at density. Right, I'll see you then.